This is R.D. Sharma solution, class 12th, chapter 3, binary operation, exercises 3.2. Now the first question is, let star be a binary operation on n defined by a star b. So star is on n, natural number, and this is defined by a star b equals LCM, lowest common multiple, of AB for all a and b belongs to capital N. So the first part is find 2 star 4, 3 star 5 and 1 star 6. So LCM of 2 and 4 is what? 2 and 4, how do we actually do it? This is how we write it. We start with 2, so 2 ones are 2, 2 is a 4, so 2 into 2 is 4. 3 and 5, it will be 15, 5 3 is 15. 6 and 1, it is 6 into 1, 6. Now the second part is, check the commutativity and associativity of star on n. So in order to find out commutative facility and then associative, so a and b belongs to n, and a star b, if it is equal to b star a, that is a star b is given as LCM a comma b, and a star b, if it is equal to b star a, then it will be commutative. Okay, so LCM of AB, if you take AB LCM, the LCM of BA will also be same. Okay, we just saw that if we take say 3 and 5, so the LCM of 3 and 5 and LCM of 5 and 3, they both are same, 15. So A star B is equal to B star A, that means it is commutative. Now coming to the associative property. Associative means A star B star C equals A star B star C. First we will do, or we will take in bracket B cross C. This operation first we will see. And the second part we will see A cross B first. Then we will operate with the next one. So if I give you 3 values. So first we have to find out the LCM of B and C. Then the result of this will be taken and it will be the input as a B with A. For example, 1, 3 and 5 I am taking. So 1 star 3 star 5 is nothing but 3 and 5, what is the LCM? 15. So now 1 and 15 LCM is 15. Similarly here also. 1, now we'll do it 1 and 3 first. So 1 star 3 is 3 and 3 star 5, that is 3 and 5 LCM is 15. So they both are same. That is, this is also associative. Question number 2. Determine which of the following binary operation are associative and which are commutative. So the first part is, it is star on n, defined by, how it is defined, a star b is equal to 1 for all a and b belong to n. Okay, so whatever you do, the result is going to come as 1 only. Whatever you do, if you take any value from the natural number set a and b, b cross a cross b, whatever you do, it will always be 1. So b star a is equal to a star b, that means it is commutative, because eventually it will come as 1 as given in the question. Okay, now a star b star c, I am doing the associative now. A star b star c and a star b star c. First we will do the b star c. So b star, any of it will give you 1. So a star 1 will be equal to, again a star b is 1. So a star 1 and 1 star c, whatever you do, it will come as 1, as the question is saying. So 1 will be equal to 1. That is, this is associative. Star is associative with respect to the set natural number. Now the second part. Now this is a NCERT question, and also in CBSE 2008 also it has come. So we'll start with the commutative. Commutative means a star b should be equal to b star a. Okay, these are the a and b are natural number. So a star b is, how it is defined, a plus b by 2. So a star b is a plus b by 2. What is b star a? It is b plus a by 2. But we know a plus b is equal to b plus a. So we can always write it as a plus b by 2. So they both are same now. So you can say that these two are equal and it is commutative. Coming to the second part, which is the associative part. In associative part, a star b star c is equal to A star B star C. So we'll do the B and C first in the first part, and then the A and B, then with C. So A star B star C. So what is B star C? B plus C by 2. Let us write it here. B plus C by 2. What about A star B? It will be A star B is, by the definition, A plus B by 2. We'll write here A plus B by 2 and then star C. Okay, now this is the first part. This is the second part. And we have to add them and divide by 2. So A is the first part. The second part now is B plus C by 2. And this is divided by 2. And what will be here? A plus B by 2 is the first part. The second part is C divided by 2. So first I'll do the numerator. We'll take the LCM 2 and then 2A plus B plus C by 2. And there is 2 also in the denominator. Here also A plus B plus 2C divided by 2, and there is also a 2. So what do you get? See, this is 2A and this is 2C. They are not same. So the star is not associative on the set natural number if this is defined. Okay. So it may be commutative, but it is not associative, this particular case. So let me tell you about the example also. You can just have a look at example. Take A as 1, B as 2 and C as 3. Both ways you can do. The way I taught you, or you can use the example also. So A, 1, B, 2 and C, 3 we are taking. So 1 star, 2 star, 3. 2 star 3 is what? 2 plus 3 by 2. And 1 star, this is 2 plus 3 by 2, that is 5 by 2. 1 star 5 by 2 is 1 plus 5 by 2 by 2. And that is giving you 7 by 4. Next time we'll do 1 and 2 together. So 1 plus 2 by 2, A plus B by 2 and star 3. So it is 3 by 2 star 3. So 3 plus 3 by 2 plus 3 divided by 2. So what do you get? You get 3 by 2, that is 3 plus 6 by 2, 9 by 2, and 2 is already there, 9 by 4. So this is 7 by 4, this is 9 by 4. So what do you get? This is by symbols, and this is by actual values. So both ways you can verify that star is not associative on the natural number. Now question number 3. Let A be any of the set containing more than one element. That is, this is the definition that the set should not be, it should be non-empty. So we have a, let star be a binary operation on A defined by A star B equals B. So whenever you do A star B, B has to come. The second value has to come. Okay. Is star commutative or associative on A? So A is coming from A, B is coming from A, but the second value will be the result. So let us start with the commutative. A star B equals B star A. So A star B, B will come. B star A, second value will come. So A will come. So B is not equal to A. So this is not commutative. Star is not commutative on this set. Coming to associative. A star B star C equals A star B star C. Okay. So we'll take B and C first, and here we'll take A and B. Always the second value will come. So B star C will be C, A star C. Here B will come. So we have B star C. Here the second value will come. So C will come. Here C will come. Second value. So C is equal to C. So the star is associative on A. It is not commutative, but it is associative. Now this question number 4 has around, in the edition which I am discussing, has around 13 parts. 13 parts. Every time you have to talk about commutative and associative, whether the star is there or not on that particular set. So the first part is star is on Z, defined by A star B equals A plus B plus AB. And A and B is coming from where? On Z. From Z. Z from integer. Okay. So this, let us start with the commutative. Now all the questions you have to do like this only. Okay. So we'll discuss first few and then we'll take pace. So A star B equals B star A, that is what you have to prove in order to be commutative. A star B is what? A plus B plus AB. B star A is what? Just replace A by B. So you have B plus A and A is here AB. Okay, BA. Now you can always write like this. This is A plus B. A into B is B into A. So you can write it as AB. So A plus B plus AB is equal to A plus B plus AB. That means it is commutative, right? Associative. Now in associative you see this A star B star C equals A star B star C B and C first, and here we'll take A and B first. So one by one. A star. B star C is what? We'll just replace A and B by B and C. So you have B plus C plus BC. B plus C plus BC. Here also A star B is already given, A plus B plus AB. And then you have C here, star C. Okay, now you see here. See, this is the first value and second value. First value is A. Second value is B plus C plus BC. So you have to write whole of the value. B plus C plus BC. And now you have to multiply these two values. That is A into B plus C plus BC. B plus C plus BC. Let me multiply it first. So A plus B plus C plus BC plus AB plus AC plus ABC. Okay. Now this is the first one. Now let me change the color and we'll do the second one. Okay. Now what do we get? So let us take the first one as A plus B plus AB. It is not AC, it is AB. I'll just change it and multiply. And then you have to add with C. And then you have to multiply C with A plus B plus AB. Okay. So this is A plus B plus AB. And then we have the C. So A plus B plus AB, and I've written wrong. I'll just change it. So A plus B plus AB, and then we have a C. Then we'll multiply also. This is AB. Okay. So A plus B plus, then you have A, this is AB, and we in the place of AC it is C. So just write C. Then AC plus BC or CB plus ABC. Now ABC is already there. Then you have BC also. Then AB also you see the third one. Okay. Now AC also you see. And ABC is also there. That means these two are exactly similar. That is, the star is associative on Z. It was commutative also and associative also. Coming to the second part. As I said, there are 13-14 parts, right? So we'll check the commutativity. The star on natural number defined by A star B is equal to 2 raise AB for all AB belongs to N. So A star B equals B star A. That is what we have to prove for commutativity. So this is 2 raise AB, this is 2 raise BA. AB is equal to BA. You can always write A into B as B into A. So these two are equal. A 2 raise AB equals 2 raise AB. So the commutative property holds the star on N. Now coming to the next property, which is the associative. Okay. Let me change the color. A star B star C equals A star B star C. We'll do the A and B first, or rather B and C, and then A, B later. So BC is what? 2 to the power BC, and this is 2 to the power AB, now star C. So this means what? You have to take the 2 to the power A and then A dot multiplied by 2 to the power BC. Here 2 to the power AB into C. Now you can clearly see these two are not equal. There is a vast difference between these two. The values are not same. You can just say that these two are not equal. Associative, it doesn't hold. Third one. Third one is star on Q defined by A plus B equals A minus B. Please remember the 12th question which is coming, 12th part is exactly same. So you have to just look it very carefully. So this is defined on star on Q defined by A star B is A minus B. So A star B equals B star A. If it is there, then it is commutative. A star B is A minus B and B star A is B minus A. They are not equal. A minus B is not equal to B minus A. So this star is not commutative on Q. Q, that means the rational number. Okay. Now let us go for the associativity. So A star B star C equals A star B star C. We'll do BC first and then AB first. Okay. So now see, BC is what? B minus C. So A star B minus C. Here A star B is A minus B star C. Okay, now we'll take these two. So this is A minus B minus C. This will be A minus B minus C. This is A minus B plus C. Here we have A minus B minus C. What do you get? They are not equal. This star is not associative on Q. Now the fourth part. The fourth part is saying the symbol has changed. I'll just call it as cross only. Okay. So this is defined as A cross B is defined as A square plus B square. A square plus B square. So A star, I'm just calling it as star. Okay. The symbol is something different, a round and a dot in between. So B, A star B equals B star A. So this is A square plus B square. This is B square plus A square. They both are same. So you can always say that this whichever symbol is this is commutative on Q. Now coming to the second part, associativity. So A star B star C equals A star B star C. So first this B and C, then A and B. So A star, what is this? B square plus C square. Here we have A square plus B square. Then symbol C. Now first we have to take A square, then we will have to take B square plus C square whole square. So B square C square plus whole square. And here you have A square plus B square. You square it. A square plus B square whole square plus C square. Okay. Now I'll just open it. This is A square plus, this is B raised 4. B square square is B4 plus C square square C4 plus 2 into B square C square. Here you have A4 plus B4 plus 2A square B square plus C square. Now what do you see? They are not equal. They are not equal. So this star or whichever symbol is this is not associated. The fifth one. The symbol is O here. So O on Q defined by AOB. Let me call it star only. Okay. So A star B is equal to AB by 2. So A star B equals B star A. If it is equal, then it is commutative. So A star B is AB by 2. B star A is what? B A by 2. That is AB by 2. A into B is B into A. So you can just equate them. This is commutative. This is commutative on Q. Now coming to associativity. Associativity is C. We have AOB, OC, AOB, OC, B and C first, A and B later. So A, operation BOC is BC by 2. Then we have AB by 2, operation C. So first this 2 and they were divided by 2. So A into BC by 2 divided by 2. Then we have AB by 2 multiplied by C and then divide by 2. Okay. So you get ABC by 4. Here you get ABC by 4. They are equal now. So this operation is associative. The sixth one. Sixth one is star on Q defined by A star B equals AB square. For all AB belongs to Q. So let us see one by one. Commutative, by now you have understood well. A star B has to be equal to B star A. Then it will be commutative. So AB square, this is BA square, they are not equal. Its commutative is not there. We will do it fast, right? Let us take pace because we have a lot of questions to do. The second one is the associative property. A star B star C equals A star B star C. We will do this one, then this one. B star C is BC square. We have A star BC square. AB square here. Star C. Now these two. First you have to take and second one you have to square. So A B square C to the power 4. Here you have AB square and then the square of C square. And they both are not equal. So this star is not associative on Q. Then we have the seventh part. Seventh is star on Q defined by A plus B is equal to A plus AB. For all AB belongs to Q. A star B equals B star A. So A plus AB equals B plus AB. They both are not equal. Just say it is not commutative. They are not equal. A plus AB is not equal to B plus AB. Okay. Coming to the associative. A star B star C equals A star B star C. First we'll do these two. Then we'll do these two. So we have this B star C. What does it mean? This is B plus BC. So A star B plus BC. This is A plus AB star C. Okay, now A star B plus BC. First, A will replace by A, but B will replace by B plus BC. Similarly here, A plus AB, then again A plus AB, but we have multiplied it by C now. What do you get? A plus AB plus ABC. Here A plus AB plus AC plus ABC. So there is an extra term AC here. So star is not associative on Q. It is not associative here. Now the eighth one. The star on R defined by A star B equals A plus B minus 7 for all A and B belonging to R. So A star B equals B star A. What does it mean? A star B is A plus B minus 7. B star A is B plus A minus 7. You can always write A plus B as B plus A. So it is commutative. Coming to associative, second part. So associative, we have A star B star C equals A star B star C. First we'll do it BC. Then we'll take AB. So A star BC is what? We'll replace A and B by B and C. So B plus C minus 7. What do you get here? A star B is A plus B minus 7 and star C. So now we'll replace the first part, A by A, but B by B plus C minus 7. So A plus B plus C minus 7, and A minus 7 is already there. We have A plus B minus 7. In place of B, we'll write C, and minus 7 is already there. We have A plus B plus C, minus 7 is minus 17, minus 14. A plus B plus C minus 14. Just check it. It's not minus 17, it is minus 14. So they are equal. Coming to the ninth part. We have star on Q defined by A star B is equal to A minus B whole square. So A star B equals B star C. A star B is A minus B whole square. B star A is B minus A whole square. Now what do you see here? This B minus A whole square is eventually equal to A minus B whole square only. How do we do this? We will take a negative one, or you can write B minus A as minus of A minus B. Why we will take negative outside? Because it is square also. So this negative whole square will become positive. Right? I hope you got the idea. No, I'll just do it for you. See, B minus A whole square, I can write it as minus A minus B and whole square. Okay, so this negative 1 whole square and A minus B whole square, minus 1 whole square is 1, A minus B whole square. So they both are equal. So this holds, commutative star is on Q. So I'm just saying it that they are equal. That is why it is commutative. Coming to associative. Now in associative, you have A star B star C equals A star B star C. If they are equal, then it is associative, otherwise not. So A star B minus C whole square, and we have A minus B whole square here, star C. We'll take both values, subtract them and square them. That is A minus B minus C whole square, this is the second term, whole square. And then we will square all of them. Okay, all of them. A minus B minus C whole square and then whole square. Okay. Now the next one is A minus B whole square. The first term is A minus B whole square. This is the first term. Then we have the second term, negative C or minus C. And then we'll square all of them. Now you see, if I open it also, it's very clear that they won't be equal. On the left, you can see very well when we open it, what do you get? I'm not opening it because it will take a lot of time. But the only thing is, you can very well see that this is not associative. So the next one is 10th one. So we have the star on Q defined by A star B equals AB plus 1. A star B is AB plus 1. So A star B equals B star A. Now replace A by A, B by B, AB plus 1. Here B by A and A by B. BA plus 1, AB is BA. So these two are equal. It is quite commutative here. Coming to associative. Let us see whether it is associative or not. So A star B star C equals A star B star C. First BC, then AB. So A star BC is what? BC plus 1. And then here we have AB, so AB plus 1, and then star C. So the first term is A, second term is, the B is BC plus 1. So A into BC plus 1 plus 1. There we have AB plus 1 into C plus 1. What do you get here? ABC plus A plus 1. Here also ABC plus C plus 1. So there is a mismatch in A and C. A and C is a mismatch. That is why star is not associative on Q. Now 11th one. Star on N defined by A star B equals A raised B. A raised B, it is exponential. So A star B, B star A, A raised power B, B raised power A, they are not equal, so just it is not commutative. Then coming to associative. Associative, so A star B star C equals A star B star C. So we'll do this BC first and AB. So this A, BC is B raised C, AB is A raised B, and then we have C. This will be A raised to the power B raised C. A raised B raised C. Then we have A raised B, and then we have raised C. A raised B C. It is basically A raised to the power BC. But this is not. It is A raised B raised C, and they are not equal. They both are different. This is not associative on N. Now the 12th one. Star on Z, A star B equals A minus B. A star B equals A minus B. Since we have already done this in the third part, so you can just refer it, or I'll just do it here. A star B, B star A, this is A minus B, this is B minus A. So this is not commutative. It's quite clear. This is not commutative. So as I'm saying, the third part question, previously it was on Q, now it is on Z. But still, the result doesn't change. Okay, now coming to the associative. Associative A star B star C equals A star B star C. BC will take first, then we will take AB. A star BC is B minus C. And then we have AB as A minus B star C. So A minus B minus C. Here A minus B minus C. This is A minus B plus C, because the negative is outside. So when you see these are not equal, that is why it is not associative on Z. Okay, the 13th one. So star on Q defined by A star B equals AB by 4. Now if you just see the fifth part which we have just seen, it is almost similar. So A star B, B star A star B is AB by 4, B star A is BA by 4, AB and B are same. So this is quite commutative. Now coming to associative. Associative says what? Associative says A star B star C equals A star B star C. BC will take first, then AB will take. BC is BC by 4. Here we have AB by 4 star C. Now this is star. So A star BC by 4 is A into BC by 4 divided by 4. Here you have AB by 4 into C by 4 by 4. This is AB by ABC by 16. This is ABC by 16. So they both are same. Star is associative on Q. Okay, if you have other additions, you might have these questions also. So your solution is in front of you. The idea you have already known now. So I hope you'll be able to do these all. Question number 5. If the binary operation O is defined by AOB equals A plus B, B minus AB on the set Q minus of minus 1. That means all the Q, that is the rational number, but minus 1 is not there. Okay, only minus 1 is not there. Of all rational numbers other than 1, show that O is commutative on Q minus 1. Okay, so what we are trying to do here is Q minus 1. What do we do in commutative? AOB is BOA. Now you see, AOB is A plus B minus AB. This is already given. A plus B minus AB. And then we have here BOA. That is, just replace A by B. B plus A minus AB. Okay. Now only this 1 is not there. So just change this A and B position. You see, they both are same. There will be only a problem when you have a -1, right? So that will be a problem, but since it is not there, we are not taking that set having that number. So that is why this is commutative. Otherwise, there may be a problem. It is commutative. Question number 6. Show that the binary operation star on Z defined by A star B equals 3A plus 7B is not commutative. What does commutative means? See, A star B is equal to B star A, then we can say this is commutative. A star B equals B star A, commutative, right? Are they equal? 3A plus 7B, now replace A by B. What do you get? 3B plus 7A. Are they equal? Don't seem to be. But we cannot just say like that. Let us prove it with certain values taken from Z, that is the integers. Let us take A as 1 and B as 2. You can take any value. So 3 into A is 1 and 7 into 2 is 14. Here 3 into B is 3 to the 6 and 7 into 1, that is 7. So you get 17 here and you get 3 to the 6. 6 plus 7 is 30. They are not equal. So star is not commutative on Z. Now question number 7. On these set Z of integers, a binary operation star is defined by A star B equals AB plus 1 for all AB belongs to Z. Prove that star is not associative on Z. It is not associative on Z. Okay. So associative means what? A star B star C equals A star B star C. So A B C will do first, A B then. So A star B C. So just replace A with B and B with C. So B C plus 1. Here you have the same thing, A B plus 1 and then star C. Again. Now here we take A as A and B as B C plus 1. So A into B C plus 1. B C plus 1, and then you have plus 1 equals, now same thing, first AB plus 1, then you have C, so multiply them, AB plus 1 into C plus 1. So what do you get here? ABC plus A plus 1, here you get ABC plus C, ABC plus C plus 1. Okay, now A and C are different, others are same, so we say that star is not associative on Z. So if you see the earlier question what we did, 4. The 10th part was exactly the same. Question number 8. Let S be the set of all real numbers except -1. So -1. The first first part of question number 4 is absolutely the same. So I'm going to skip certain part of it, but certain things we need some explanation. Okay. So this let S be the set of all real numbers except -1. So -1 is not there. And star be an operation defined by A star B equals A plus B plus AB for all A comma B belong to S. So we have A plus B plus AB. Determine whether star is a binary operation on S. If yes, check its commutativity and associativity. Also solve the equation 2 cross x cross 3 equals 7. Okay. So for binary operation, what do? We are taking a set without a -1. So you are taking a real number set without -1. Real number, as I said, it is the father of all set. So everything will come here. So you have A cross B and A and B we are taking from this real set, which cannot be -1. Please remember, because R doesn't have -1, A and B cannot be -1. And what is this? A plus B plus AB. So what do you see here when you don't have a -1? Then if you multiply and add whichever number from real number, it will be a real number. So by observation, it seems that it is a binary operation. But we cannot just say and write like that. So we have to prove it. How do we prove it? So what do? We will try to say that the result A star B is actually -1. What I'm saying is A star B, which is A plus B plus AB, is actually -1 because R doesn't have -1. The real number, only -1 is not there. So A plus B plus AB, we will try to put it as -1. We'll try to put it as -1 and then we'll try to find out what are A and B. because A and B are from real set without -1. So A plus B plus AB, which is eventually A star B, I am putting it as -1. So let us say that -1 comes out. Okay. So if it comes as -1, whether A and B are defined for this real number, let us see. So I'm just putting it as -1, and now just we will take this equation and rearrange them. So A plus B plus A, B plus 1. Now A and AB can take together, and A plus AB, and then you have B plus 1 equals 0. You can take A, 1 plus B is there, then we have B plus 1 equals 0. Now you can take 1 plus B or B plus 1 common from here, and because they both have this content, so B plus 1, then inside this only A plus 1 will remain. This is equal 0. Now B plus 1 equals 0, A plus 1 equals 0. That means B is either -1 or A is -1. But as I said, this real number set is not having -1. So this is a contradiction. When we say that A plus B plus AB becomes what? -1, A and B are also -1, which is a false. So we can safely now say that A star B is a binary operation. I hope you got the idea. Okay, this part is being done. Now second part is commutation and association. But let me just tell you that we have already done this question. So we will just skip this commutation and associative part. But there is one more thing which is being asked on the equation. We'll do that. 2 star x star 3 is equal to 7. So this we have to do. So A plus B plus AB. So we'll take A as 2, B as x. So 2 plus x plus 2x. And then we have into 3 equals 7. Now this one will take as A. So this is 2 plus 3x eventually. And A as 2 plus 3x, B as 3. Again we'll apply A plus B plus AB. So 2 plus 3x plus 3 plus AB. So 3 into 2 plus 3x equals 7. Okay. So 2 plus 3x plus 3. Multiply 3 inside. So 6 plus 9x you get equals 7. Okay. So 3x plus 9x is 12x. And you have here 6 plus 3, 9, 9 plus 2, 11. So plus 11 equals 7. Now you can just shift this 11 there. 12x is 7 minus 11. 7 minus 11 is -4. So 12x is -4. And now x will be equal to -4 by 12, which gives you 4 is a 12. So -1 by 3. So this is x is -1 by 3. Okay. Okay. Question number 9. On Q, the set of rational numbers, star is defined by A star B equals A minus B by 2. Show that star is not associative. So not associative, let us do by the actual way first. A star B star C equals A star B star C. First we'll take BC, then we'll take BA and try to find out whether they are equal or not. See, this is not equal. I am just putting equal sign. We will just try to see whether it is equal or not. So A plus B minus C by 2, because A cross B is A minus B by 2. Here we have A minus B by 2, C. Now they are equal, then only it will be binary, this what we are trying to see, associative. Now A will take as A, B will take as B minus C by 2. So A minus B minus C by 2 divided by 2 equals A minus B by 2 minus C divided by 2. Okay. What do you get here? 2A minus B plus C divided by 2 was already there, 2 to the 4 you will get. Okay. So 2A minus B plus C divided by 4 equals, and here we have A minus B minus 2C divided by 2 to the 4. Okay. Now it's quite easy to see that we don't have an equality. They are not equal. But you cannot say that. You have to prove it. And we can prove it using example. Let us take A as 1, B as 2 and C as 3. So just put A as 1, B as 2, C as 3. So 2 into 1 minus 2. And then we have 3 here divided by 4. So 2 minus 2 cancels out. 3 by 4 you get. Here you get A minus B. So 1 minus 2 minus This 2c is 6 divided by 4. So 1 minus 8 by 4. So what do you get? You get negative 7 by 4. Okay, so 3 by 4 and negative 7 by 4 are not equal. It is not associated. Question number 10. On Z, the set of all integers, a binary operation star is defined by a plus b, a star b is equal to a plus 3b minus 4. Prove that star is neither commutative nor associative on Z. Associative is a star b equals b star a, replace a by b. So here directly a plus 3b minus 4 you will write and just replace a by b here. B plus 3a minus 4, so it's quite easy to see they are not equal. They are not equal. But still we need to put some values here and then we just put a as 1 and b as 2 and then you can check. Because a and b are belonging to z, z are integer. A you can take as 1, b as 2. So just put a as 1, 1 plus 3 into 2, 6 minus 4. So 1 plus 6 minus 4, you get 7 minus 4 is 3. On the right hand side we have 2 plus 3 into 1 minus 4, so you get 3 plus 2 is 5, 5 minus 4 is 1. 3 is not equal to 1, so it's eventually that it is not commutative. Now we have to do the associative also. So let us see the associative part. Associative part. Okay, we'll use this again. A star b star c equals a star b star c, and we'll see whether they are equal or not equal. So a star b star c equals a star b star c. We'll do this BC first. Here we'll do AB. And since it is a plus 3b minus 4, a plus 3b minus 4. So we have b plus 3c minus 4. Here you get a plus 3b minus 4. And this operated by c. So now take a as a, b as b plus 3c minus 4. So a plus 3 into b plus 3c minus 4 equals, this first we'll use it as a and 3b minus 4, and then we have that 3 into c minus 4. So a plus 3b plus 9c minus 12 minus 4 equals, I'm just saying equal, I'm not saying that they are equal, I'm just equating them and then we'll prove whether they are equal or not. A plus 3b plus 3c minus 8, a plus 3b plus 9c minus 16, and we have a plus 3b plus 3c minus 8. So what all are equal, just cancel them out. What do you get? 9c minus 16 equals 3c minus 8. So what do you see here? They are not equal. Or you can find out the value of c also from here, and you can prove that c doesn't belong to z. But still you can see very well. You can put any value c and finalize it. Question number 11. On the set Q of all rational numbers, if a binary operation star is defined by a star b equals ab by 5. So prove that star is associative on Q. So associative is a star b star c equals a star b star c. I'm just saying it is equal, not equation sign is just left hand side, right hand side. They are equal or not, we'll just see. So a star b is what? ab by 5. Then we'll operate it with c. Here you have a bc by 5. Okay. Now ab by 5 star c. So ab by 5 multiplied by c divided by 5 equals, now a bc by 5 divided by 5. So you have abc by 25. Here we have abc by 25. So they are equal. That means it is quite associative. Question number 12. The binary operation star is defined by a star b equals ab by 7 on the set Q of all rational numbers. Show that star is associative. I'll just show you here because it is exactly similar to the previous one. So a star b is ab by 7. So bc by 7. A into bc by 7, that is abc by 49. Same thing here, ab is ab by 7. A star b. Then ab by 7 star c is ab by 7 into c divided by 7. So here you again get abc by 49. So they both are equal. Star is associative on Q. Please remember this question is exactly similar to the previous one. So I just gave you an idea here only. Okay. Question number 13 here. On Q, the set of all rational numbers, a binary operation star is defined by A star B is A plus B by 2. Show that star is not associative on Q. Since this question we have already done, okay, A plus B by 2. Let me tell you. Question number 2, part 2. Okay. This already we have done, so I'm just skipping it because question number 2, part 2, NCERT CBSE 2008 we have already done. So there are certain added questions also, because in my edition there are around 13 questions. Some more are there. You can just have a look. Okay. Now this 3.2 is over. Thank you so much.